Good afternoon. So I think students have to come. Okay, we'll start. So good afternoon, one and all. The last class of this week. So tomorrow you have a Sunday, you can enjoy. So we'll complete this class in this session. Okay, right. So in the last class we have discussed about the derivation of the vertical submerged object in a fluid. How to get the formulas by deriving the problems. Now in this class we'll discuss about the vertical plane submerged surfaces, their associated problems. So in the last class I already mentioned that the hydrostatics plays a vital role during the whenever the bodies are submerged in a liquid. So we have seen whenever the object is greater than the outside force, then the objects will submerge. That is just like ship. Whenever they are equal, it will immerse. Whenever there are less than, it will float. So like this, you are having three phenomena which we have discussed in the last class. Now, according to the various theories, so we are having some derivations. Based on the derivations, we are having the problems in this introduction of hydrostatics. Here, the hydrostatics force is submerged in a liquid. Either horizontally we are submerging, vertically we are submerging, inclined we are having a submerged, curved surfaces may submerged, and also what is the center of pressure acting on the body. Now we see each derivation step by step along with the problems. Now yesterday's class I have already mentioned about the various momentum of inertia what we will get in the other subject, strength of materials. Here also you can see the rectangle area. What is the rectangle area? What is the center of gravity? What is the momentum of inertia? What is the momentum of inertia about the base? These are the formulas. You see the triangle also. You are having the center of gravity G at that one point. You are having the CG from the base. You are having the area BH by 2. You are having the momentum of inertia passing through the CG and momentum of inertia about I naught. Next surface you have seen a circle. What is the area of a circle? What is the center of gravity from the base? What is the momentum of inertia about an axis passing through CG and parallel to base IG? Next, we don't have a moment of inertia about IG, so it is kept 0. Next, the other plane is trapezium. See the trapezium, you are having area, small area at the top and bigger area at the bottom. So you see the height, you see the x. So center G is the gravity, center of gravity. Now if you see the CG from the base, x is equal to 2a plus b by a plus b to the power of h by 3. Next, area, a plus b by 2 into h. Next, momentum of inertia about an axis passing through center of gravity and parallel to the base. So this is the formula what we have got, that is a square plus 4ab plus b square. A square plus 4ab plus b square, 36 to the power of a plus b into h cube. These are the objects which are immersed in the liquid. While doing the problem, these are the plane surfaces, that is rectangular plane surface, triangular plane surface, circular plane surface, and trapezium plane surfaces. These surfaces may be immersed in the front view or it may be the side view. So while doing the problems, you can see if the circle is in this direction, front view, if you want to see the side view of the circle, it just look like my first year drawings just look like a line, If you take a trapezium also, it is just looking like a line. So like this, you are seeing the objects in the front view and the side view or the top view. Now with these objects, we will start the problems. So we are entering into the first problem of vertical objects suspended into the water. Now see, so in every in every question of this type of problems, you will get a figure. So if you see the top surface of a water, in it you are having a rectangular object is submerged. So if you see the rectangular object, you are having the pressure at the point. You are having the center of gravity G. So from the center of gravity to the upwards, you are having the height h bar and h naught for the P. So if you see this one, if you see this rectangle, the same things you have to apply, the same formulas you have to apply for this problem. Now see the problem. A rectangular plane surface 2 meters wide, 3 meters deep. See here, this is a rectangular surface 2 meters wide, 3 meters depth. It lies in a vertical plane. It lies in a vertical plane of plane in a water. So ఇది ఎట్లా ఉంది, vertical గా ఇట్లా షీట్ లాగా కాకుండా vertically downwards it is planned. Determine the total pressure and the position of center. Determine the total pressure and the position of center of pressure. So determine the total pressure P and the position of center of pressure on the plane surface when its upper edge is horizontal. So upper edge is this one. The upper edge is horizontal and coincides with the water surface. So the upper surface is coinciding with the water surface, and B 2.5 meters below the free water. 2.5 meters. So when the object is 2.5 below. So second case lenti, first case lo ee rectangular plane anedi first place lo దీని మీద just float అవుతుంది water surface మీద. Second point ఏంటి, 2.5 distance లోపలికి మునిగిన తర్వాత టోటల్ గా సబ్మెర్జ్ అయితే అక్కడ what is the momentum of inertia under pressure. So that is the question asked. So ఇప్పుడు మీరు ప్రాబ్లమ్స్ ఎగ్జామ్స్ వస్తున్నప్పుడు you have to see whether ఇక్కడ ఇది చూడాలి. So you have to see the object is vertically or it is horizontally or it is a with some angle or a curved. So based on that you have to do the problem. Right. Now take the given data. Width of the plane surface is equal to P 2 meters. Depth of the surface is equal to D 3 meters. Now take the first one coinciding with the upper water. We'll see the upper edges coincide with the water surface. That is the figure. See the 3-point figure. Total pressure given by the system as, so you know the F is equals to ముందు మనం derive చేసాము. Initial గా కూడా మనకి we know what is the F. Force is equals to rho into G into A into H. So మనం ఈ calculate చేయాలి కాబట్టి we are taking this formula. Okay na? Okay. Next. One second. My laptop got power source discontinued. Okay, now if you see the formula by using the formula, yes, sorry, okay. Now if you see the F is equals to rho into G into A into H, where P is equal, rho is equals to 1000 as we know, G is equal to 9.81, that is also we know that. Now area, what is the area? Directly you can say 3 into T is equal to 6 meter square. Then what is the H here? H is equals to half into, we see here, this one, D by 2. What is D here? This one. So that's why by taking this one, 3 by 2, that is equal to 1 point. D by 2 into either. So H dash is equals to, the table lo meeru x by 2 అని ఉంది. D అంటే ఏంటి? X is equal to D by 2 అనేది. What is the D here? D is equals to this 3. So మనకి 3 నే కదా? See here 3. 3 by 2 is equal to 1.5. Then applying in the formula, F is equals to 1000 into 9.81 into 6 into 1.85. That's equals to 88,290. Now force వచ్చింది. Next what we have to find? We have to find the G. Now the depth of the center of pressure is given by the equation 3.5. Now మనం చెప్పుకున్న 3.5. H is equals to Ig by AH plus H dash. Now, where Ig is equals to momentum of inertia about Cg of the area of the surface. Now apply this one. Momentum of inertia about Gg is equals to across the momentum of inertia, this one. BD by C, center. BD by 12. You have to take this formula. BD by 12. BD cube by 12. So that is BD cube by 12 is equals to 2 into 3 square divided by 12. That is equal to 4.5 meter cube. Next. So what is the H star here? H star. I put in local. Substitute 4.5 by area into H dash plus H bar. So other substitute cheste. So finally we will get the H value, that is 2 meters. So you got the height. Okay. Next. BB20 2.5 meters below the water surface. Total pressure F is given by 3.1. So this formula malli apply cheyali. Next case lo em cheyali? This object is coming down with a 2.5 meter depth. Now applying the same thing, H dash is equals to where H dash is distance of Cg from the free surface of the water. That is equals to 2.5. అంటే ఇది కలుపుకోవాలి కదా distance 2.5 plus 3 by 2. అంటే 3 by 2. X by 2 means 3 by 2. That is equals to 4. Now applying this in this F 1000 into 9.81 into 6 into 4, we are getting this. Now the center of pressure is given by the same formula. Apply the same formula. Now substitute Ig. What is Ig here? Initially this could be 4.5. Ig we got here 4.5. Ig we know 4.5. A is equals to 6. H is equals to 4. Now substitute in this, you are getting the direct formula, the direct answer 4.1875. So right. So like this, you have to do the problem based upon the direct formulas and based upon the figure shown. So like this, you have to do the pressure calculation, center of gravity calculation. So I think it is very easy to understand these problems. Next, we'll do the next problem. Next. I will take other plane, that is a circular plane. We'll take a circular plane. Now see here, determine the total pressure on a circular plate. So circular plate, determine the total pressure of a diameter 1.5 meter, which is placed vertically in the water such that the center of the plate is 3 meters below the free surface of water. Find the position of the center of the pressure. So center of pressure kanukomanadu, at the same time the total pressure kuda kanukomanadu. Now draw a line, water surface, water. The circular object ఎంత కిందకు ఉంది 3 meters below the free surface. Free surface నుంచి 3 meters కిందకు ఉంది. సో అప్పుడు 3 meters కింద ఒక లైన్ తీసుకొని అక్కడి నుంచి అది సెంటర్ ఆఫ్ G అని పెట్టుకొని అక్కడి నుంచి వారు మేకే సర్కిల్. సో దీనికి నో ఇన్స్ట్రుమెంట్, నథింగ్, జస్ట్ మేకే సర్కిల్. రఫ్లీ యూ కెన్, వితౌట్ స్కేల్ యూ కెన్ డ్రా. నౌ GP. సో GP ఎప్పుడు పైన ఉంటుంది, P ఎప్పుడు కింద ఉంటుంది, గుర్తుపెట్టుకోండి. రైట్. G under pressure. Now you have to find the total pressure. Now apply the same formula. Now here the object is circular kabatti area maripotundi. Indaga manam cheppindi area rectangular kabatti area is equals to B into D. Length untundi, but here area is equals to pi d square by 4. So pi into D anta 1.5 square by 4 is equals to 1.767. Then H is equals to anta ichchadu, H is 3 meters. H naught, H dash is equals to 3 meters. Now applying the formula, F is equals to 1000 into 9.81 into 1.767 into 3 Newton. So you are getting the force. Next, position of the center of pressure H star. H star ide kada, H star formula malli meeru teeskondi by using the mundu chesina yesterday chesina derivation lo is the H star. Now Ig is equals to pi d cube pi d to the power of 4 by 64. ఈ ఫార్ములా ఎక్కడి నుంచి వచ్చింది? You have to know this one. Center of Cg కాబట్టి pi d 4 by 64. By using this one, we substituting this formula here. Now pi into 1.5 by 4 by to the power of 4 by 64. Now the Ig is equals to 0.2. Then what is the H star? 0.2485 divided by, apply this one, A into H bar. So that is totally H is equals to 3.0468. So that is the total pressure what you are getting, the position of the center. So this one, center of pressure H star, and total force what you are, total pressure what you are getting, this one, the total pressure ochindi. So we got the total pressure F and the center of pressure H star, right? So like this you have to do for the simple circular problem. So I think it's very simple, I think. So మనకి ఒకటే ఒక ఫార్ములా, ఈ ఫార్ములా గుర్తుపెట్టుకోవాలి. వాట్ ఇస్ దిస్ ఫార్ములా? ఇది వెర్టికల్ కి మాత్రమే, వెన్ ఆర్ ద ఆబ్జెక్ట్స్ ఆర్ వెర్టికల్లీ ఉన్నప్పుడు మాత్రమే మనకి అప్లికబుల్ అవుతుంది. సో ఈ ఫార్ములాస్ గుర్తుపెట్టుకోవాలి. ఈ ఫార్ములాస్ ఎక్కడ ఉన్నాయి? ఆల్రెడీ టేబుల్స్ లో ఉన్నాయి, రైట్? మొమెంటమ్ ఆఫ్ ఇనర్షియా, Ig. Next one. So now we are taking a rectangular which is where the breadth is in the horizontal side. ఇందాక ఫస్ట్ కేస్ లో మనకి ఇట్లా కాకుండా ఇలా ఉంది, ఇప్పుడు ఇలా ఉంది horizontal. Now see, a rectangular slice gate is situated on a vertical wall of a lock. The vertical side of a sluices is d meters. So the d meters vertical side. Horizontal side is d meters. And the d meters in length, and depth of centroid of area is p. Centroid area is a p. And the p and the H star below the water surface. Now prove that the depth of pressure is equal to p plus d square by 2. Now take the given data. What is the depth of vertical gate? D meter. Width of vertical gate? D meter. So b, d, I think. Next, what is the area? B into d square, b into d square. What depth of CG? Depth of center of gravity, this one. H is equals to P into meter. Now H is equal to depth of center of pressure, which is given by the equation. Now we apply this same equation we are applying here, where G is equals to VD cube by 12. VD cube from the table what we already know. Now H star is equals to Ig. Ig means VD cube by 12 by A into H plus H. Ivanni substitute cheste A into A and B into D. H is equals to P, okay, and plus H dash is equals to P. That is equals to, so cross cheste D square by 12P plus P, or P plus D square by 12P. So we got the proof. So whatever the proof we got, that is matching with the question. So like this also you can get the problems. Next. Now we'll take other shape that is nothing but a triangular shape. Now determine the total pressure and the center of pressure. Total pressure and F. Total pressure means F. Center of pressure means X star. So we have to find total pressure F and the center of pressure star. Okay, center of pressure star. Determine the total pressure and center of pressure on an isosceles triangle. Plate of base 4 meters and altitude 4 meters. Base and altitude 4 meters and altitude is also 4 meters. Now the base is immersed vertically on the top surface layer. So base ekkudundi, height depth em ivvaledu, certain depth, just it is on the surface of the water vertically in an oil. So here the liquid is oil and water. What is specific gravity? 0.9. The base of the plate coincides with the free surface of the oil. So the base of the triangle coincides with the free surface of the oil. Now take the base of the plate. B is equals to 4 meter. H is equals to 4 meters. Now what is the area? Area is equals to B into H by 2. That is 8 meters square. Now what is the specific gravity of oil? S is equals to 0.9. What is the specific density of oil? Density of oil is equals to 900 kg per meter cube. Now the Cg from the surface of the oil. H bar is equals to 1 by 3 H. ఇది ఎలా వచ్చింది ఈ టేబుల్లో ఉంది. See here. ఇది తీసుకున్నాడు. CG from the base. CG from the base. The CG from the base is H by 3, that is equals to 4 by 3, 1.33 mm. Now the pressure same. F is equals to rho into G into A into H. Now substituting in that, we are getting the answer. Now the center of pressure H star is equal to apply the same formula. ఇప్పుడు మనం ఏం కనుక్కోవాలి IG కనుక్కోవాలి, right? IG is equals to BH cube by 36. మనకి ఆల్రెడీ ముందు ఆ ట్రయాంగిల్ టేబుల్లో ఉంది by 36. This one. Now B into 4 into 4 cube by 36 is equals to 7.11. So 7.11 ఇక్కడ substitute చేసి area 8 into 1.33 plus 1.33, that is equals to 1.99 meters, that is 2 meters. Center of pressure H is equals to 2 meters from here to here. Is a 2 meters. Is a 2 meters. So like this you have to do for a vertically immersed object in the any fluid. So ఇంకొక ప్రాబ్లం ఉంది దీని లోపల. A square aperture in a vertical slide, a square aperture in a vertical side of a tank has one diagonal vertical and is completely covered by a plain plate hinged along one of the upper sides of the aperture. This is a plate where you are having the dimensions A, B, C, D. Total the diagonal is 2 meters. 2 meters. See this is the front view, this is the side view. So along the height is 2 meters, width is 2 meters. So it is just like a square aperture where it is hinged under. So it is hinged to one side along the one of the upper sides of the aperture. The diagonals of the aperture are 2 meters long and tank contains a liquid specific gravity of 1.15. The center of aperture is 1.5 meters below the free surface. So center ఏమన్నాడు? The center of aperture is 1.5 meters below the aperture. Specific gravity ఏమన్నాడు? That is 1.5. Now calculate the thrust exerted by the plate, by the liquid, and position of the center of the pressure. H star కనుక్కోమన్నాడు. H star and the what is the thrust it is developed. What is the thrust it is developed. Now given the diagonals of the aperture ఏంటి? AC BD. AC BD is equals to 2 meters. That is a given area. The area of the square aperture. What is the area of the square aperture? Area is equals to area of ACB. Area of ACB plus area of ACD, that is equals to AC into BO by 2 plus AC into OD by 2, that is equals to 2 into 1 by 2 plus 2 into 1 by 2, that is equal to total 2 meters square. Total 2 meters square. Now what is the specific weight of a liquid? It is 1.15. Density of a liquid, rho is equals to 1.15 k. 1000 add cheste you are getting 1150. Then what is the depth of the center of pressure from the free surface? H dash is equals to question that is 1.5. H dash is equals to 1.5 meter. Now what to find? First thing you have to find the thrust. Thrust is nothing but the pressure. Apply here 1.1150 into 9.81 into 2 into 1.8, 1.5, that is equals to. Now the center of pressure H star is equals to, apply the same formula because it is vertically suspended. Now IG is equals to moment of inertia of ABCD about the diagonal AC. That implies MO, momentum of inertia of triangle ABC about AC plus ACD about AC, ABC plus ACD. So AC into OB cube divided by 12 plus AC into OD cube by 12. So E formula applies this. E formula, by because it is you are having a two halves by taking the square bit. Square bit and across the same. Whatever the triangle and square or rectangle, you have to take BD cube by 12. So applying this one. So రెండు areas cover చేస్తున్నాం కాబట్టి 2 into 1 cube by 12 plus 2 into 1 cube by 12 is equals to 1 by 3 cube. Now H star lo substitute చేస్తే H star this one 1 by 3 divided by area is equals to 2 into 1.5 plus 1.5. Now the center of pressure P is equals to 1.611 meter. That's the answer for the question. So I think hope you are understanding the problems, right? Just anyone just raise your hand or message me, or you understanding or not. చాలా తక్కువ మంది వస్తున్నారు క్లాస్ కి, very few. So it should be notified. So are you understanding the problems? Just message me yes or no. I will repeat it. అర్థమవుతున్నాయా? Message me or talk to me. Unmute your mic and you can talk to me. Getting the problems? You can chat me or you can talk to me. You are getting the problems or not. తెలియాలి కదా మీకు అర్థమవుతుందా లేదా అని. రవితేజ, సందీప్, స్నేహలత అర్థమవుతున్నాయా ప్రాబ్లమ్స్? Okay, right. Next. So మనకి vertical గా whenever the body is submerged in a liquid, so we have understood by taking some of the problems. ఇంకా మనకి ఎన్ని ఉన్నాయి? ఇంకా 3 కాన్సెప్ట్స్ ఉంటే this unit will be completed. What is the next one? Horizontal గా submerge అయితే ఎలా ఉంటుంది, inclined గా submerge అయితే ఎలా ఉంటుంది, curved surface submerge అయితే ఎలా ఉంటుంది. So with this 3, by next class we can easily complete the first unit. Okay na? Next. The next one is objects horizontally suspended into the liquid. The horizontal objects, plane surfaces submerged in the liquid. How horizontally it is submerging? Now take the same experiment. Consider a plain horizontal object immersed in a static fluid. So where the water is not moving, a place locally, take an object, maybe a square, triangle, rectangle, trapezium, circular. Consider a plane horizontal surface immersed in a static fluid. As every point of the surface is at the same depth. So every point on the surface is at the same depth from the surface. The pressure intensity will be equal on the entire surface and equal to pressure is equal to rho into GH, where H is the depth of the surface. ఏం చెప్తున్నాడు ఇక్కడ? Whenever, for example, take a square, for example, take a biscuit. ఒక బిస్కెట్ తీసుకుని వాటర్లో వేయండి. వెర్టికల్గా అయిపోయింది కాబట్టి ఇప్పుడు ఫ్లాట్గా హారిజాంటల్గా వేయండి. So whenever a biscuit is floating or immersed in a liquid, what are you saying? As every point ఏంటి? The 4 points on this point and this point and this point and this point. So these 4 points of the object, the same depth from the free surface of the liquid, the pressure intensity will be equal, and P is equal to rho GH, where H is equal to depth of the surface, the total depth of the surface. So if you see the just smaller derivation, so let area is equals to, let A is equals to total area of the surface. A is equals to total area of the surface. Total area of the, next you see the water free surface. The object is మనకి ఇట్లా స్ట్రైట్ గా పెడితే అర్థం కాదు కాబట్టి, సారీ స్ట్రైట్ గా పెడితే అర్థం కాదు కాబట్టి ఫిగర్ లో మనకి ఇట్లా స్లాంట్ గా it is shown in this direction. Now, so whenever the object is in a flat, the P and G lies at the same point. So H bar and H star are equal. H star and H bar are equal. Now, see the total area. A is equals to total area of the surface. Now take the total force. F on the surface is equals to same this one. What we applied here. Now take P is equals F is equals to P into area. What is the P here? Rho into G. This is P is equals to rho into GH into A. Rho into GH into A. Now, totally we are calculating F is equals to rho into G into A into H. So the same formula what we have discussed in the vertical problems also we are discussing now. Now, if you see the H dash, the depth of CG from the free surface of the liquid H. H star is equals to depth of the center of pressure. Keep in mind the H star means the depth of the center of the pressure. H bar is the depth of center of the CG from the free surface of the liquid. So both you are having at a certain H. Why? As per the condition, the 4 points are floating on the surface of the object or immersed constantly. The height will be same. Thereby, the center of gravity G and the center of pressure P are equal. This will be the sum of the problems. Now take the first problem. So the figure shows a tank full of water. So here you are having a tank, T-shaped tank, where you are having a full of water. Find the total pressure on the bottom of the tank. So you have to find the pressure, the total pressure at the bottom of the tank. The weight of the water in the tank, weight of the water in the tank. Total pressure, weight of the water in the tank, hydrostatic paradox in the results 1 and 2. Width of the tank is 2 meters given. Now see the figure here. See the figure. You are having the water tank. The width is 4 meters. The height is 3.06. 3.6 meter. So the mouth opening is a 0.4 meter. Now what is now? Now from the question, write the given data. The depth of water on the bottom of the tank. The depth of water on the bottom of the tank, H1 is equals to 3 plus 0.6. Now the depth of water from the above the tank, 3 plus 0.6, 3.6. Which is the width of the tank is 2 meters. Length of the tank at the bottom is 4 meters. Okay. The depth of the tank is 2 meters. Length of the tank at bottom is 4 meters. Okay. Now, area of the bottom and the area 4 into 2. 4 into 2. This width into length. Area is equals to 8 meters square. Then first one is the total pressure on the bottom of the tank. F is equals to rho into G into A into H. Now substituting value 1000 into 9.81 into 8 into 3.6. You are getting the total pressure which is. Now what is the weight of the tank? Rho into G into volume of the tank. So in the volume you have to consider, because it is a body, here you have to consider length into width into height. Now what is the weight of the tank? Rho into G, that is common, into volume of the tank. Rho is equals to 1000 into 9.81 into 3 into 0.4. This one 3 into 0.4 into 2 plus 4 into 0.6 into 2. That is 3 into 0.4 into 2 plus 4 0.6 into 2 under this one. 3 meters. 3 meters into 0.4 is, what is the 0.4 here? This one. 3 into 0.4, 3 into 0.4 into width of the tank 2 meters, 4 into 0.6, 4 into 0.6 into width of the tank, that is 2 meters, that is equals to 1000 into 9.81. So adding this one, totally substituting, we are getting the weight of the tank is 7632 newtons. What is the next thing you have to find? The hydrostatic paradox. That's all. So we got the differences. What the difference in the results we got? So that is a 28,000 to 2,528 newtons, whereas here you are getting 70,632 newtons. By taking the width of the tank is 2 meters. Right. Like this, the simple thing where you are using the horizontal plane surfaces. Horizontal plane surfaces. So the third category is inclined plane surface submerged in the liquid. Inclined plane surface submerged in the liquid. So in the initial two places, vertically we have practiced some problems. Vertically we have practiced some problems. Horizontally we have practiced some problems. Horizontally we have practiced some problems. Now we will take the objects which are submerged in the liquid, inclined. So if you take any object, if you take a square, rectangle, trapezium, or any circular plate, when the objects are immersed inclinedly, making an angle, how the problems are, we are reacting, how we are doing the problems in this case. Now consider a plane surface of arbitrary shape. Take any shape, arbitrary shape, and any definite shape, immersed in a liquid, so such that a way that a plane of the surface makes an angle theta. So whenever the object is immersed in a liquid, generally it takes an angle, first angle theta. So angle theta. So ఈ ఆబ్జెక్ట్ మనకి ఫ్రంట్ ఫేస్ లో చూపిస్తున్నారు. దీన్ని మనము సైడ్ వ్యూ లో చూస్తే ఇలా కనిపిస్తుంది. సో whenever you see this object, మనకి అర్థం చేసుకోవడానికి it is shown in this way. Right? Now it is making some angle theta with the water surface. With the water surface of the liquid as shown in the figure. Now see the water surface, on the water surface of object mirror dump cheste, it is making an angle with theta. This is an angle with theta. Is side view ni open chesi opposite lo chusi front view lo chuviste, you are having center of gravity under total pressure F, the center of gravity, then height ekkada start avutundi, h star is equals to p nunchi start avutundi, g center of gravity, g is equals to h bar start avutundi. Now if you take a small cross section for finding the formula, taking a small cross section area dA, right? So now applying, then what is the distance here? The distance from P to surface of water is y star, from center of gravity to surface of water is r. Now take, let A is equals to total area of the surface. H bar is equals to depth of CG of inclined area from the free surface. H star is equals to distance, this distance of the center of pressure from the free surface. Angle is equals to made by the plane of the surface. So you can write any like theta is equals to angle made by the object, and you simply go line or switch. Now, so you are derivating the plane of the surface is produced meeting at a free liquid at a point O at the surface O, at the surface O. Then OO is the axis perpendicular to the plane surface. Thereby, y dash is equals to distance of CG with respect to OO, and y star is equals to distance of center of pressure from OO. So here we are taking two cases. One case is with respect to O, other case is normally going to the water object. Now considering a small strip of area, so to get a derivation, you have to take some small area from the arbitrary shape. So what is the shape? What is the area you have to? There is a dA at the depth of h from the free surface. Now the pressure intensity is equals to P is equals to rho into G into h. Now the pressure force dF on the strip is equals to dF is equals to P into area of the strip. P into area of the strip. That implies rho into GH into dA. Rho into GH into dA. Total pressure applied on the whole area F is equals to integral dF, that is equals to rho into P into dH. Now from the figure, from this whatever the object you are seeing, H by Y is equals to H dash by Y because these are both equal. H by Y is equals to H by Y is equals to H star by Y star. That is equals to making an angle that is sine theta. So if you make a triangle here, the theta like this, automatically you are taking the sine theta. Why? Because ఇది మనం కన్సిడర్ చేయం కాబట్టి opposite side by hypotenuse. So you are taking the sine theta. Therefore, H is equals to Y sine theta. Maybe H dash is equals to Y dash sine theta చెప్పొచ్చు. H star is equals to Y star sine theta ఎలా అనగానే చెప్పొచ్చు. Then F is equals to integral rho G into Y into sine theta. So ఇది తీసుకోండి. Now apply here rho delta integral rho G H ఎంత Y sine theta. So Y sine theta into dA. That implies rho G బయటికి తీసుకో, rho G sine theta బయటికి తీసేసి Y of dA. Therefore integral Y of dA is equals to A into Y dash. Therefore the distance Y dash is equals to F is equal to rho D into sine theta into Y into A. Therefore as H dash is equals to Y dash sine theta. So substituting here, we are getting F is equals to rho into G into H. Now if we integrate delta of rho G sine theta Y dA is equal to rho G sine theta integral of Y A. So like this we are substituting. So finally what you are getting? We are getting the H dash, that is the center of pressure. So generally you not get any derivations. So this is the equation. H star is equals to Ig by sine square theta by AH dash plus H dash. So initial గా ముందు మనం ప్రాబ్లమ్స్ లో ఏముంది, sine square theta లేదు, ఏది vertical గా చేస్తున్నప్పుడు. Why? Because we don't have any theta there. Now ఇక్కడ object is making an angle, certain angle to the surface of the water, then obviously we have to prove H star is equals to Ig sine square theta by H dash plus H dash. So this is the formula for inclined objects whenever the object is submerged inside the body completely or partially. So like this we have to consider when the object is inclinedly placed. So with this formula you are having some problems to discuss, right? So these are the problems. So I think the time is less than 1 minute. So manamu we have discussed all the problems, each and every case for a circular object, a square object, triangle object, a trapezium object. So like this we can make any number of problems based upon this simple formulas and the process. So we will stop at this point. Which one? Sorry. So we will stop here. Inclined plane surface submerged. So we will continue the class in the next time. So you get this videos in the YouTube link. Just open it and see it. Thank you for listening.